Hi, my name is John Sharpe, and I'm coming to you from sunny Southern California in Santa Monica. And just going to give you a quick talk on some of the things that have helped me running macOS at scale for CI/CD systems. And some of these things I've kind of learned from Linux and Unix before and have helped me out. So hopefully you can get something out of this talk that might help you out too. So just a quick blurb about me. I started with Unix and FreeBSD, and then I moved on to Linux and Mac OS, BSD being the Berkeley software distribution of Unix, which probably some of you are familiar with. I like to describe systems as code, and what that means is maybe configurations, the software that's installed, packages, and the services that are running on these hosts. I built environments for various different systems, games, apps, financials, and test automation. And currently I work as a systems engineer at Snapchat on CI/CD infra, which is pretty sprawling. It can be everything from physical hardware devices that we might make ourselves to iPhones that are running test automation, Android devices that are running test automation, builds that are happening on Mac OS hosts, and then the tests that are being run on, say, a developer makes a change to a branch in their infrastructure or in their code for an app, and we will like build it and test it on a phone. So it's a pretty sprawling environment, but really we're just going to talk about Mac OS and some of the things to do that have helped us with that. So some of the challenges with distributing Mac OS for CI/CD are repeatable environments. So when we're running builds, we might have people change stuff on a system, and we need to be able to reset a system back to a known state. And the same for when we're running tests. It's a little less in the test because we're not executing other people's code as much, but we're taking a build and installing it on a device, running things through the XE test framework. And it's a lot of UI testing and performance testing generally. And then some of the other things that give us problems or are challenges in repeatable environments is the Xcode toolchain when we're trying to update that. That's always, Xcode now is bigger than Big Sur. So it's trying to push out Xcode to like hundreds of machines. That can also be a difficulty that you might have in this sort of space. Consistent configuration, that's also a problem we might run across. Some hosts will be offline and they come back on, and then we need to basically make sure that they are able to either bootstrap themselves if they're starting up new, or set themselves back to a known good state with configuration, etc. Some of this has to do with like we'll have periodic jobs on these hosts or things that happen when the hosts start up. So in this space, we've used tools like MDS, which is spoken about here earlier, and NetBoot. We still use NetBoot on our older machines, which we'll talk about shortly. And then we'll do a little quick diversion down troubleshooting with logs and talk about locks and local and distributed and how they can help you. So probably many of you are familiar with ASR. What is ASR? It's the Apple Software Restore. This is from the man page, and you can see the BSD reference in the Apple man pages, which always makes me happy to see. But why would we want to have a wrapper around ASR? And why would you have a wrapper around anything? Well, you can kind of think of launchd as a wrapper. Launchd is calling other processes, expecting some output or return, and making some decision based on it, maybe restarting something, etc. So why would we have a wrapper around ASR? Well, when we found when we were going from Catalina to Big Sur that we couldn't actually use the same process that we used up until that point for our older machines, which are basically trash cans and the 2014 Mac Minis. So we basically would run Imager, which would run ASR, and then it would crash. Here you can see it in this screenshot here. It's actually applying the image. We're running ASR, pulling our image off of a local HTTP URL, and then we would crash with this illegal instruction. So upon further investigation, we found that, well, our image was getting installed And I'm not entirely sure why the crash is at the end. I believe it's something to do with validation. We're also running a netboot environment of macOS 10.13. So I think I tried later versions and it wouldn't actually install the Big Sur image at all. So I'm not sure if it's something with that particular version, but it would stop, but we would get an imaged host. So how did we handle this? Well, we made a wrapper for ASR. We moved the binary ASR to ASRO, and we created a wrapper ASR with kind of like a try-catch approach if you're familiar with Python or other programming languages, but we just made a simple wrapper with bash. So here we are calling the new path that we put the binary at. We are passing it all of the args that it would get, setting the output to a temporary place, and we're sending standard error to the same place. That's what the bit at the end is. And then we'll capture the failures and make a decision whether we should have a return code of 0 or 1. Previously, we were getting a return code of 1, and that was actually stopping our imaging workflow. So another place we've used a wrapper is with CSRUtil. So what is CSRUtil? Configure system security policies. This is basically change some firmware bits in the MV RAM so that your system will behave a certain way. So we have two use cases for this. One is we like to be able to use dtrace to take a process and see what is going on with it for simulators or other things and report back. The second usage of CSRUtil is basically to be able to bootstrap our systems by writing into Etsy. So we use Etsy cron tab, which we'll talk about in a second for bootstrapping and other periodic jobs. But when so for our newer machines that are basically cheese graters, so we do kind of have an infrastructure of Mac Minis, trash cans, and then cheese graters are our new build systems. And for those, we were using MDS to deploy these systems, but we were not getting CSRUtil disabled because after the Big Sur install, it would make some decisions based on setting CSRUtil back to a state that it liked somewhere in the install. So we don't really have control over this. So what we were able to do is run a wrapper in the background around CSRUtil and keep at just disabling it. So, I mean, I know this isn't the greatest method, but sometimes we need to get our jobs done and we have to use the tools that are available to us. So in a recovery environment, bash is one of the tools that is available to you. So we did a quick little thing where while true, colon is a shortcut for true, do a CSRUtil disable, sleep for 1/10 of a second, and done. And then send the standard output and the standard error to this file. And then secondly, background it, and then use the disown, which is basically a fancy no-hup. You don't actually have no-hup in a recovery environment. So moving on a little bit to scheduling. So when you're running a system that's going across a lot of machines, you need to schedule all kinds of things. Like maybe sometimes we'll have processes that will leave a lot of logs behind, and we need to basically be able to clean them out periodically. Or we have things that crash on our systems and other people's jobs, so we have to be able to clean out certain areas of temp files they might leave behind. One thing which I'll just mention here too is a little short thing is that man-k will let you search for any string within the Unix man pages, Unix, Linux, BSD, macOS man pages. And basically in the first example here, we're searching for the string periodic. So periodic is a sort of older scheduling system that's available in some Linux Unixes, and it's also available in macOS. I use it sometimes, but it's a little esoteric. There's usually a directory, something .daily, .hourly, etc. And you put a file in there, and then it will get like run on that periodic schedule. So it could be useful, but I sort of just glaze over it because it's not as easy to use as cron tab. So let's go on to cron tab. This is sort of our bread and butter of scheduling. So this is an example of we're listing our cron tab -L, and then mail to, we don't want to send any mail. So you generally don't want to get mail from cron because that will usually go to a postfix daemon on macOS, and nobody's going to read that email. So usually our jobs, we will emit a metric to Grafana, et cetera, to have some knowledge of what happened with this job. So in this first example, we're just running every minute user bin echo, and then echoing hi to a temporary file and sending the standard error to the same place. And if we see that we cat here, the temporary file, there is no user bin echo. Echo is a built-in with bash or any shell that you choose, CSH, et cetera. So if we edited our cron tab. So, and this is in particular a user cron tab. This cron tab is associated with one user, and all the jobs that run from this cron tab will be as that user ID. So, and then here we've edited it, and then we sort of run it again. We have it running again. It's running every minute, and it's going to send the output to this temp file, and you can see it put hi. So one of the key things here is that when you do schedule things this way, to get output, it's always good to send it to a temp file or have logging within the code itself. But in this case, it's good to see what it does on startup, because early crashes are always the hard ones to detect and debug and figure out what's going on. So that is a little bit about user cron tabs. So continuing on with scheduling, as here's another example of using man-k and searching for the string cron tab. And we can see it's in two of the Unix man pages. One is, I believe one is for users, and then the other is like for the system library documentation. So you can see some syscalls throughout the man pages, et cetera, and search them with man-k. Here's another example of scheduling. So etc cron tab. So cron has a facility of having a global cron tab file, and it's in etc cron tab. And if you put at reboot as the time when you want to run this job, it will do it on startup, which is very useful for us because we will be trying to bootstrap systems. And that's one of our methods of bootstrapping them. That's why we use that CSR util. We'll write into etc cron tab at reboot after the machine image, and then next image, it will kick off a job for us. And that will basically be our bootstrap job, which will join a cluster, make a configuration management, figure out what the identity of the machine. We have an infra API that has a backend of a database, and then run the configuration back against this machine. So it's a useful technique. So in etc cron tab, we have our mail to again, and then at reboot. And the one difference with etc cron tab is that you specify the user. So in this case, we're specifying root as the user that this job will run as. And then we're running bash-lc. So that's going to basically load in your environment variable. It's going to give you a login shell with bash sort of simulated. So basically it's going to run your bash profile, bash RC. It's going to get your environment in there. We're going to run this script, and then we're going to send the output here. And that's only on reboot. And then here's a second thing, and a little just tidbit. I kind of found this job, and I thought it was kind of funny because when Apple first released timd, so we're very time sensitive on if you're running a lot of machines, you're very time sensitive on them. And so timd would crash on us, and we would get some time drift, and then some machines wouldn't authenticate because we're using some backend authentication for it, et cetera. So I just had this little job here to basically run NTP date. This runs at the top of every hour, the first 0 minute. And then this is basically the C name for time.apple.com, I believe. And, send the output to temp NTP date out and the standard error there. So not something you need to do typically if things are working, but sometimes you just need to put something into the system that will keep things working, whether it's like cleaning logs, etc. And this is one thing I like about etc cron tab. It's a central place to go and look at what's going on a system as far as scheduled jobs go. And then it's a central file that we can distribute with, you can use Ansible, Chef, Puppet, or any sort of distribution system that you would like to push these changes out to and keep them versioned and get somewhere. It's a great way to keep your systems in code. So moving on to logging, there's really a few things I'd like to cover on logging. One is dmessage, and you have that on Linux and you have that on macOS. And this is an example where we're seeing a GPU break on a trash can. So it's sort of, you're not going to get all of the process logging, but you will get things that are happening at the hardware end level. So it can be useful sometimes. And then there's a log command, which some of you might use and know, which kind of, I believe you get this information from the console. There's a graphical console to see this, but I'm usually SSH into machines. So I'll run something like sudo log show, and then you can tell it debug info, and you'll get a lot of info on processes that are basically logging to the central logging daemon and running it into a binary file. So this is very similar to systemd and journalctl, which is the logging interface into Linux systems. So another thing is sometimes log processes don't actually log into the central logging process, but they might just log into a file themselves or through syslog, which is an older logging system. And so in this case, we're looking at this process, which is PID 289. We're taking an LSOF of it and we're grepping for log. We're filtering out any of the open file handles that would have the word log in them. And so here we can see that it's pointing us to this location for the log file. And another little tidbit is that you can use locate on macOS, which is something that I was familiar with from Linux. And when you run locate, the locate command, it's a terminal command. When you run locate, it will basically, the first time it'll tell you, run this launchd process, and which I believe interfaces with the Spotlight database of your files, but you can basically use this to search for a file on your file system. In this case, I'm looking for the log that we already found it above, but just as an example, it's like this log lives here, and then there's multiple of them. It's getting rotated. So finally, locks. So we use locks a lot. Locks are a good way when you have jobs that are running, you want these jobs to be distributed. Well, there's really two use cases for logs. One is to have a log only run in one place, and the other is to have a scheduled job run in only one place. And the other is to basically have a scheduled job only run once on a system. So imagine this, you have a job that runs every hour, and it starts taking longer than an hour to run. If the next one that comes along is running and it's causing load on your system, and it takes an hour and a half, and then you start building up these processes, your system will get slower and slower. So a lock is a very useful thing to have when you are running jobs and don't want them to step on each other, and you want them to run in serial, or you want them to run distributed and run on only one place. So here is the first example is using a program called flock. And I left all this until the end because the first things in this talk were all built-ins in macOS, and these are a few things that you can install outside for locks. So the first one is using this command called flock. So in this example, we have a cron, a user cron tab-l, and we're running flock. And basically -n means if you can't get this lock, then exit immediately. Don't wait until you can get the lock and run the program. So the lock in this case, flock means file lock, is pointing to this file path. So I just call them .lock. It makes it easy to distinguish them from other things. And then it's running a command called datesleep, a program called datesleep. So the program called datesleep basically just runs date and sleep for 100 seconds. We can see it down here in the process tree. So it appends the output, the double greater than signs, to temp date_sleep.out. And then this sends standard error, which is file handle 2, into the same location. So in the next part of this example, you can see we cat temp date sleep, where the output is getting appended to, and this job is actually running every minute. And it does skip a minute. So you can see it sends the date the first minute, it skips a minute, and then it sends the date the next minute. And something super useful, actually I like the output better on macOS than Linux, is pstree. So pstree here, we're showing that we're looking for the string date sleep in the process tree. And you can see it, date sleep. And then if you follow the process tree up through its parents, you can see cron is running this program. It's running the lock, it's running date sleep. And then above that, launchd is running cron. So that's sort of an example of using pstree and how to use a local lock to keep a job running only once. So distributed locks are a little more controversial, I guess. So I once wrote a program called dlock, and I got a lot of, and I tried to use a MySQL temp file, MySQL temp data structure to handle the lock. And I'm like, I've written the greatest distributed lock ever. And, you know, somebody was like, no, you haven't done that right. So there's easier ways to deal with it. And one of the programs that we use is Console. Console is a great little program that will give you a lot of different things. It gives you service discovery, service mesh. Service discovery being, I have a name, like a DNS name, and then there's a bunch of nodes behind it that run that service. You might have health checks that bring those nodes in and out. They might reboot, whatever, but the service is still there and discoverable by a bunch of hosts. It's basically load balancing. So Console gives you that. It gives you a key value store that's distributed amongst all the nodes running it. It gives you a distributed lock and some other things, which you know, you can go look it up. But in this case, we'll just keep it to the locks. You can write distributed locks with Console. So why would you use this? Basically, if you had 10 machines that want to run a job, you want to, or say 3, you have 3 machines, they want to run a job, and you only want it to run on one machine at a time. You could basically have it so it exits, or you could have them all wait until they can get the lock, and one would run, the next would run, the third would run. So it's a useful technique when you want to make some sort of job more redundant across a bunch of machines. So for us, we use like some head nodes that control other things, and we might have a job that we don't want to, basically we only want it to run in one place at one time, but we want to make sure that if we have some of the head nodes down, that the job will still run. So here in this example, we're using etc cron tab, the system cron, and we have it running every 10 minutes as the user John Sharpe, this console lock, and then it has a timeout of 1 second. So if you can't get the lock within a second, exit. And then we're using this string hi. This is basically the name of the lock. And then we are running this command, echo hi. I probably should have used a different word instead of the same across all the places, but we're echoing hi as our unit of work, and we're sending the output to this file, and we're sending standard error to the same file, same place. So that's one way you can use locks, distributed and local, to help you. And that's it. That's the last slide. Thanks. These are some of the small things we use in my current employment, which is Snapchat. So to help us run macOS build and test systems at scale. Thanks.